Hello class, today we'll look at chapter 3 on connecting local area network to wide area network. Okay, these are the objective of this chapter. We'll look at why routing is necessary for hosts on different network to talk to each other. What is a default gateway? Why do we need a default gateway? How do we set a default gateway? What kind of IP address can be used for the default gateway? What situation where a default gateway is being used, and the different ports on the router. Okay, here's the outline. We look at how do we interconnect local area networks together, a default gateway, the need for a default gateway, when do we need it, and how do we connect a local area network to a wide area network using a router. Okay, what is a local area network? In chapter 1, we define LANs as network that is used in a small area, like for example within a building, within an office, and even like within your home. Your home itself is a small local area network. So your phones, your laptops, your iPads, your sister or brother's phones are all connected to the home Wi-Fi, which provide this local area network. Okay, and all of you are all connected to the same local area network. So local area network normally is used to provide services, application to people within the same organization. So like small business, small campus, a home, and so on. And in lab 2, if you remember, we use a switch, and the switch is used to connect to different PCs. And in lab 2, we realized that PC in the same network is able to talk to each other when you're using a switch, and PC in different networks will not be able to talk to each other if they are connected to a switch. So local network is also sometimes refers to PCs that's in the same network. Okay, how do we define PC in the same network? Okay, if you remember in lab 2, we use both the IP address and the subnet mask. We use both this information to tell the laptop what network does it belongs to. Okay, for example, in this case, IP address for laptop A is 192.168.1.33 with a subnet mask of 255.255.255.0. If you remember, this subnet mask indicate that the first 24 bits of the IP address is the network bits. It indicates the network. Okay. Again, remember subnet mask is a 32-bit number, separate, and each number here is an 8-bit number. That's why the maximum number is 255. So if it's 255, this means that subnet mask is 1234567.1234567.1234567.8. So 8, 16, 24. And the last number is all 0. So we have 8 bits of 0. So using this subnet mask, laptop A know that the first 24 bits, which is 192.168.1, these three numbers are the first 24 bits, are the network bits, and the last number 33 is the host bit. So laptop A knows that all the PC in the same network as laptop A will have the first three numbers in the dotted decimal format, or in binary, the first 24 bits the same. It's always 192.168.1. So some PC may be .34, some PC may be .35, some PC may be .200, some PC may be .254. But the first three numbers is always 192.168.1 if they are all in the same network as laptop A. So if you look at this IP address for laptop D, IP address for laptop C, and IP address for laptop B, they are all in the same network as laptop A. And of course, you also need to look at the subnet mask. So their subnet masks are all the same, and this means that they are all in the same network because all 4 laptops start with 192.168.1. So they have the common network portion if they are in the same local area network. Okay, and when we try in lab 2, we realize that if they are in a different network, this means that they do not have a common network portion. They can't ping each other. Okay, and when they have different network portion, this means that they belongs to different network. Okay, this concept is very important when it comes to this chapter 3, when we talk about routing packets between different networks. Okay, how do we connect local area networks together? That means how do we connect different network together? Like, or how do we connect PC belonging to different networks together so that they can talk to each other? Lab 2, using a switch, we realize we can't do that. How about using 2 switches? For example, I have switch A connected to LAN A, and LAN A, okay, with this subnet mask, okay, this means that the first 3 numbers of all the IP address of this PC connected to switch A, they all start with 10.10.10, and perhaps this is 10.10.10.10, this is 11.12.13, for example. So they all start with 10.10.10.10, and they all belongs to the same network, the 10.10.10.0 network. Switch B happens to belongs to a different network. It all start with 20.20.20.20. So it's in a different network as LAN A. And LAN B PCs are connected to switch B. If we connect switch A and switch B together, hosts in LAN A will still not able to talk to hosts in LAN B. Okay, connecting 2 different switches together does not mean that they can talk to each other. They will not be able to talk to each other. When you connect 2 switches together, okay, basically or virtually you are just creating one big switch that connects all the PCs together. Okay, it's just one big switch. So you are just expanding the number of ports on a switch. So for example, this is a 4-port switch, this is a 4-port switch, connect 4 devices. If I want it to be an 8-port switch, okay, I just connect these 2 switches together, then this will become a big single switch. Okay, so how do we or what do we need to do to make PC in LAN A talk to PC in LAN B? Okay, we need a new networking device called a router. So we need to put a router between switch A and switch B so that PC in LAN A can talk to PC in LAN B. Okay, so router C serves as a gateway for the 2 PC to talk to each other. Okay, something you should always bear in mind, the difference between a switch and a router is a switch switches packet in the same network. Okay, a switch switches packet in the same network. Okay, while a router routes packets between different, okay, the keyword is different network. So a switch packet in the same network. So all these PCs are in the same network, they can talk to each other because the switch this packet to each other. Okay, and if you want PC in a different network to talk to each other, you need to use a router because a router helps to route packet between different networks. So a router connects different networks together. Okay, so based on this topology and based on the definition, okay, in this topology we'll have 2 different networks. This will be the first network called LAN A. This will be another network called LAN B. Okay, so a router connects the different networks together so they can route packet from one network to another network. Okay, notice when I draw the boundary, when I draw this circular, okay, I included E0 and E1. E0 is included in this LAN A circle, E1 is included in this LAN B circle. So E0 is here, E1 is here. Okay, these are the fast Ethernet interface of router C. Okay, router as compared to switch. Okay, the fast Ethernet interface, you need to put an IP address. Okay, on both the fast Ethernet interface. Switches, no need. You just connect, it works. But router is a bit different. Router, we will need to put IP address. We need to configure IP address on the interfaces so that it works. Okay, and what IP address to put here, it must be in the same network as LAN A, meaning this IP address must start with 10.10.10. Okay, for example, it could be 10.10.10.1, it could be 10.10.10.254. Okay, how about here? The IP address of E1 must be 20.20.20. something. So it must start with 20.20.20.20. Okay, so that it's in the same network as all the PC in LAN B. Okay, so that's why I deliberately cut this so that it includes this interface. Okay, later I'll explain why their IP address must be in the same network, okay, as the port or as it was connected to, okay, the LAN that is connected to. Okay, so this port, the IP address must be the same as the local area network that is connected to. Okay, so again, I will emphasize a switch switches packet in the same network, a router route packet between different networks. Okay, next, what is a default gateway? Okay, a default gateway normally refers to a router port, okay, a port on a router where PC, in a local area network, if they want to go to other network, they will use this port, okay, to help them to send packet to the other router. Sorry, to the other networks. Okay, so a default gateway is used by the PCs connected to the local network so that they can send packet out of their own networks to other network. So it helps to route the packet out of its own network to other networks. It's something like a main door to a house. So if you are staying inside the house, you will have to use the main door so that you can go out and see your friend, visit your friends in staying in other house. If you want to talk to your mom, your dad in that house, you do not need to use the door. You do not need to go out the door because your family are inside the house. But if you want to talk to your friend outside, you want to meet your friend outside, you need to go out of the door. So you need to find where's the door, and the door, okay, in the networking is called the default gateway, and it refers to a port on a router. So it's an interface port of the router that's connected to a local area network. It acts as the default gateway. Okay, so remember, a default gateway must be in the same network. Okay, using the same example of the door, okay, you cannot tell the PCs to use the door of another house. Okay, it must be the same door that is connected to your house. Okay, so that PC in the house knows where to find the door. You cannot use the door on another house. Okay, using another example, let's say right now you are in SP. Okay, so right now you are in SP, and SP is in the area called Dover. So you are in Dover. Okay, you want to go home. Okay, so how do you go home? Let's say your home is in Budok. Okay, so you want to go home. So how do you go home? So I will need to tell you. Let's say you're not sure how to go home, so I need to tell you to go home. You need to find your default gateway, and your default gateway is the Dover MRT station. So once you reach the default gateway, the MRT will help to send you one station at a time until it reach Budok. Okay, so this Dover MRT is your gateway to get out of Dover. Okay, so that you can reach your destination. Okay, but I cannot tell you that to go out of your SP, to go out of Dover, go to, for example, Orchard MRT. Okay, let's say Orchard MRT. I cannot tell you your default gateway is Orchard MRT because in the first place, you can't even get out of Dover to go to Orchard. Okay, you need to know where is the default gateway inside the Dover area, which is the Dover MRT. You need to know where is it before you can get out and go to other places. So your default gateway must be a place, okay, which is in the same network as you. So which is why just now I emphasized, okay, all these PC belongs to the same network. So the default gateway of all these PC must be in the same network. Okay, so the IP address that you set here must be in the same network as all these PC, so that this PC knows how to find the default gateway. So your default gateway when you're in Dover must be the Dover MRT. Okay, so this slide, okay, again emphasize that the interface of the router that's connected to this LAN A must be in the same network as the host in LAN A. Else, if you say that use a default gateway in another network, okay, it doesn't make sense to all these PC because all these PC only know how to reach the IP address in its own network. He need the default gateway for help. But if you're going to tell them that your default gateway is in another network, they can't even go there. Okay, so default gateway must be in the same network as the host in LAN A. So in this example, okay, LAN A IP address always start with 10.10.10 because the subnet mask is 255.255.255.0. Okay, so the default gateway IP address that you set here, okay, for example, you can set it as 10.10.10.1 with this subnet mask. Then PCs will be able to find where's the default gateway. If you set the default gateway to be, for example, 20.10.10.1, and then you tell all these PC to go to 20.10.10.1 to find the default gateway, this PC will not be able to find it because they realize it's actually in a different network, and I can't reach a different network unless the default gateway is in the same network as me. Then I can ask the default gateway for help. Okay, so going back to the router C, which is connected to LAN A, LAN B. Okay, so similarly, the Ethernet 1, the Ethernet port, the other Ethernet port, okay, because it's connected to LAN B and the network address always start with 20.20.20, so I give an IP address 20.20.20.1 to E1, okay, with this subnet mask. And now the IP address of this port is now the same IP address, okay, or in the same network as all this PC connected to LAN B. Okay, so this is one part where students sometimes do not know how to set the default gateway, what kind of IP address to use for the default gateway. So that's why I've been emphasizing this again and again, that the default gateway must be in the same network, okay, as the PC connected to this local area network, this LAN. How do we know it's the same? Again, look at the IP address, look at the subnet mask. This will tell you what kind of IP address you should give to the port of the router. Okay, so how do you configure the default gateway? Okay, so in Windows, we can configure it under the Internet Protocol property, the IPv4 property. Here we can set the default gateway. And when we run ipconfig command in the command prompt, we can see the IP address, subnet mask, and we can see the default gateway that has been configured. Okay, let's look at a simple exercise. We have host X 334455.1 with this subnet mask, host Y 334455.2 with this subnet mask 255.255.255.0. Okay, and we have an Ethernet 0 of router C with this IP address 334455.99 with this subnet mask. So what value should we enter for the default gateway for host Y? Okay, for host Y. Okay, so obviously over here we will enter 334455.99. Okay, this is IP address of the Ethernet 0 of router C which is the gateway for these PCs to send packet out to the other network. Okay. Okay, so the IP address for the default gateway should be 334.155.99. And notice in the earlier example, we always use .1 as the default gateway. Okay, but it is not mandatory to use or to always use .1 as the IP address of the router interface. You can use .10, .100, .200. It's just an address. It's just a number. Okay, most importantly is whatever IP address you use here, you must set it correctly on the host so that they know where to find the default gateway. So always use the IP address of the router interface as the default gateway. So when do we need to use the default gateway? Okay, it depends on this PC, whether does it need to send a packet out of its own network or is it trying to send a packet within the same network. Okay, if this PC need to send a packet out of its network, then he will need to contact the default gateway. The default gateway will be needed. Okay, if the host, the source, need to send a packet to a destination which is not in the same network. But if the source is going to send a packet in the same network, okay, so the destination is in the same network as the source, then we do not need a default gateway. The default gateway will not be needed. Okay, we'll look at an example. As a source host here, the IP address is 445.66.77 with a subnet mask of 255.255.255.0. So the first three number indicates the network address. So if this PC need to contact someone in the same network, meaning it also starts 445.66.54.55.66, he need to connect a destination that's in the same network as this source. Okay, he will just send the packet and the switch will help him. The router in this case is useless. It's not being used at all. Okay, but if this source 445.66.77 need to go to a host with this IP address 77.88.99.11, this source realized that, oh, I'm going to contact this IP address which is in a different network as me. What should I do? I will need my default gateway help. Okay, I need to ask him for help. So I will pass the packet to the Ethernet interface of this router. Okay, and then this router will help me to forward the packet. Okay, and forward the packet until we reach the destination. So in this situation, hosts need the help of a router with the default gateway. Okay, next we look at wide area network. Okay, wide area network is used to connect local area network that is separated by a large geographical area. So let's say we have two local area network, okay, that are far apart. We use a wide area network to connect them. So you connect two or more local network together, and the link is normally of a slower speed because of the distance. Okay, it's further apart, so the wire are longer. The number of wire you can use is also limited. Okay, so normally the speed is a slower speed. Okay, and of course until recently where we have the fiber optics, and fiber optics help to improve the speed of a wide area network significantly faster. Okay, a lot more faster. Previously, we are always using copper wire, which uses electrical signals. So as you are aware, electrical signals, the longer the distance, there will be more interference, there will be more attenuation. So the signal get weaker and weaker due to the resistance of the wire. Okay. But with fiber optics work on the basis of light. So it travels on the speed of light, and the signal strength does not really decrease over distance. So you use pulses of light. That's why fiber optics now is able to transmit over a long distance, okay, with quite minimal loss in speed. Okay, so it still can travel at quite a fast speed over a long distance. Okay, so routers in a wide area network. So in a wide area network, normally we only have routers. We do not have any end devices. So a wide area network is used basically to route packets, okay, between the local area network. So we do not have any end devices in a wide area network. It just basically consists of routers to help to decide the best path to forward the IP packet from the source to the destination. And finally, we look at the different ports, the different interface ports that's available on routers. Typically, a router will have a console port, auxiliary port, Ethernet ports, and serial ports. Okay, let's look at the function of all these different type of ports on the router. Okay, first, the Ethernet port and the serial port. Okay, Ethernet port is normally used to connect to your local area network. Okay, so normally you have your fast Ethernet, which the speed can go up to 100 megabits per second, and the newer gigabit Internet, which can go up to 1000 megabits per second or 1 gig. And nowadays we have the 10 gig link, so you could have a 10 gigabit Internet. Okay. Serial ports, on the other hand, is used to connect to the wide area network. Okay, because over a wide area network, normally we need to send the data across a long distance, so we use a serial port. We send the bits 1 bit at a time at a slower speed. So serial port is normally used for these purposes, okay, to connect with the routers over a wide area network. So it's normally used using serial port. Okay, how about console and auxiliary port? Okay, console port is used for so that you can configure the routers. Okay, what happens on packet tracer is if you need a router, you drag the router onto the workspace, then you click on the router, and then you can start to configure the router. But in a real live router, you cannot just take your mouse and click on the router, okay, the physical router. Okay, so what you need is you need to bring your own laptop, run some program on this laptop, okay, such that when you connect to this router, the program that you run allows you to configure the router. Okay, and what kind of ports do you connect to? You connect the console port so that this program, okay, can run commands to the console port so they can configure the router. Okay, so that's the use of a console port. Okay, auxiliary port is allow you to connect to a modem, okay, using a telephone network, your public switch telephone network. So through the public switch telephone networks, okay, and you allow you to remotely, that means you do not need to be near to the router, you can be remotely at home, configure the router, okay, through the use of a telephone network and the modems. Okay, so auxiliary port is mainly for you to remotely configure the router. Let's say, for example, the router goes wrong during Chinese New Year, and you don't feel like going back to the office to see what's wrong with the router. So if you have set up a modem at the auxiliary port of the router, you can use your own modem, connect to the public switch telephone network, and then start to look at what's wrong with the router, okay, rather than having to go back and use a console port. Okay, finally we look at how do we represent the different type of ports, the different kind of connection used, okay, for in packet tracer. Okay, the Ethernet ports, okay, are connected using a straight through cable. Okay, so a straight through cable here, a straight through cable here. How do we represent straight through cable here in packet tracer? Solid black line. Okay, so you see solid black line here, solid black line here. For serial line, okay, again remember serial line are used for wide area network. So serial line is using a red line and it looks like a thunder. Okay, so it looks like a thunder red line. Okay, this represents a serial connection. So that's all for this chapter, chapter 3. I spent quite some time on the default gateway. How do you configure a default gateway? So apparently that is quite important. So if you are still unsure, look for me during the lesson time. I'll try to explain to you again how do you configure the default gateway and what kind of IP address to use, how do you connect to a default gateway so that to make sure your network works. Okay. Meanwhile, you can start your lab 3. This will give you some practical experience on configuring a default gateway on the router, on the PCs, and then see the effect of having a default gateway and not having a default gateway.